Hello, everyone. This is the Lab 3 exercise, linked structure. The learning objective of this lab exercise is to define and implement linked structure, including implement the insertion, search, and deletion, traversal, and clean operations of linked structure. Please read this programming style file before you start. In this lab exercise, the first step, you'll need to define a class. The class name is student. You define the student class in the file student.cpp. You are supposed to implement all the member functions, including two constructors. So this is a student class, and I list all the function prototypes here. You need to implement all these member functions. And here we have a node type struct template. This is a template, so we use a generic data type T here, not the specific data type student. And here the constructor with one parameters, the parameter type is also T. So this the student class and the struct node type are put in student.cpp. This is a header file. We need to include this file in our lab03.cpp file. The main function is contained in lab3.cpp file. The main function will complete the following 6 steps. First, declare a pointer head. This pointer head points to node type object, or we say the head pointed to a node. And then the prompt user to enter student information, including the student ID and name, and then add this new student in the linked structure. So create a new node and add the new node in the linked structure. Stop adding the student when the user enters 0 as the student ID. So use a while loop to add multiple students into this linked structure. And then displays all the students in the linked structure. Still use a while loop. And then prompt user to enter the student ID, and then remove the node contain this student ID from the linked list. And then displays all the students in the linked structure. The last step, clean the linked structure, means remove all nodes from the linked structure. The expected result is this. Preempt user to enter the student information. ID is integer and the name is a string. And then add this student to the linked structure and read this message. The student is added. And stop adding the student when the user enters student ID as 0. ID is 0, and you can enter any name for this student. And then print out all the student information in this linked structure. So here I add the new node to the front of the linked structure. So the insertion order is 1101, 1102, 1103. But when we print out the student, the 1101 is at the end of the linked structure. 1104 is at the front of the linked structure. You can add the new node to the front, or you can add the new node to the end of the linked structure. And then the student ID to be removed. Prompt user to enter ID. Now the user enter 1102, remove the student with this ID from the linked structure. And then we print out the student information in the linked structure. Now we can see the 1102, the student with ID 1102 is removed. Okay, the compile. No, before we talk about the compile, let's take a look at how to implement the search and remove operation. In the module 2, the code file employee.txt. So the difference is here we store employees or the employee object in a linked structure. And now I may use this one. So for this one, the test linked employee template. In this one, we use a node type struct template. This template is same to the Lab03 exercise. And then we prompt user to enter the student employee information, add the employee to the linked structure. These are all very similar to our Lab03. Use a while loop to add multiple employees to the linked structure. And then print out the employee information in the linked structure. This part is the if statement, and then the while loop is a search and remove. Search a target employee from the linked structure, and then remove the node contain this target employee. So here we need to check if the target student is in the first node. So if it's in the first node, we use this to statement to remove the first node. So we move the head to head next and delete previous. And then use a while loop. Use a while loop to check if we can find the target employee or student from the linked structure. So this if statement. So if we're not at the end of the linked structure, that means we find the target student or employee. So else means this employee or student is not in the linked structure. So you can use the code similar to this one, but now in our lab exercise, it's about the student information. The linked structure store a collection of students, but here in this code file, this is a linked structure store a collection of employees. Okay, go back to the Lab03. To connect to the Linux lab, we will open the terminal. And so if you're a Windows user, you install PuTTY and open the terminal. If you are a Mac user, you just open the terminal window. Windows user PuTTY. And okay, so the following steps are same to the Windows user and Mac user. So the terminal, open the terminal and connect to the server. SSH and Coyote ID. This is my coyote ID. The server name is gbh3-1.cse.csusb.edu. And then press enter. Press enter, you need to enter the password. You enter your password. When you enter the password, nothing will show on the screen. You just enter the correct password and press enter. You will see your coyote ID. You will see your coyote ID at gbh3-1. So this means you already connect to the server. This is a server name. And then you connect to the Linux lab, SSH GB359 dash. You need to add a number between 1 and 10. Between 1 to 10, I will use the 7 and press enter. Now the password. So you press a password, enter the password, nothing show on the screen, but you just enter your password and press enter. You connect to the Linux lab. You will see the at GB359-7 and then the $sign. This means you connect to the Linux lab. Okay, so the next step, go to your folder, CD CSE2020, and then create, and then you will be in the CSE2020 folder. And then type the command to enter to create a folder, Lab03, and then enter the Lab03, and then use vi student.cpp to edit student.cpp. And you enter the vi, you are in the command mode. So you tap the ki, you will enter insert mode. And then you can tap the code. Tap the code, the student class and node type struct. And then after you edit the file, you exit the insert mode. You tap the key, ESC. This is the KI, and tap the key, ESC. Now you will be in the command mode. And at the command mode, you tap the :WQ. :WQ means you save the file and exit VI. Now, if after you exit the VI, you tap the LS, you will see the student.cpp file is in your folder. And then you will work on the lab3.cpp, VI lab3.cpp, and then tap the code and then save and exit. Save, exit. Okay, use the same command. And now after you exit the VI, you can see you have two files under the current directory. You have the student.cpp. You will see the student.cpp and lab3.cpp. Then compile these two files. Okay, compile these two files. You use this G++ student.cpp-c, and then the G++ lab3 2.cpp-o lab03. Lab03 is the executable file name. And then you can run the executable file ./lab3. So if your program can generate the correct result, you can use a script command to generate the log file to capture all the results in this txt file. And then the next step, you transfer the 3 files, 2.cpp file and 1 txt file. Transfer these 3 files from server to your local folder. You use cyberduck to transfer these 3 files to your local folder and upload these 3 files to Canvas. The due date of this lab exercise is here. I think it's 1 week or 2 weeks, up to 1 or 2 weeks. Please check the due date of Lab 3. And this is a Lab 3 grading rubric. The readability and appearance are worth 2 points. So in fact, the readability worth 2 points in every lab exercise. And then the correctness is worth 8 points. Please read the grading rubric before you submit your work to the Canvas. Okay, this is all about the Lab 3. Now you complete all the learning activity of Module 2. Congratulations.